Okay, so let's take a look at this paper. I need a volunteer to read this question. McCoy, thank you.
Wait, which part?
The whole thing. Read the whole thing.
Multi-step.
Okay, no, start at number 1.
Sean is constructing a Pinewood Derby car for the upcoming Pinewood Derby race with his Cub Scout pack. The car currently weighs 120 grams. Sean would like to increase the weight of the car by 10% in order to improve its racing ability. The race rules require each car to weigh 5 ounces or less. 1 gram equals 0.04 ounces. Can Sean apply the 10% increase to the car's weight and meet the requirements of the race? Show all your work below and round your answer to the nearest hundredth of an ounce.
Perfect. Okay, so this is going to be we have to do a couple different things here. We're going to have to do a conversion, right? Because what are our 2 units of measure here?
Ounces and grams.
Ounces and grams, grams and ounces, okay. Also, we're doing an increase, right? So that's kind of like on whenever we did those menu things, that'd be like adding a tax or a tip to something. So we're going to have to find a percentage of a number and then add that that value to the number, okay. So somebody tell me, what would you do first here? What would be your first strategy? What would you do, McKaden?
I would increase 120 by 10%.
Sure. Okay, so I'm going to leave it as grams. So now you guys can get your pencils out.
As well.
All right. So how do I find 10% of 120? What do I do there? Landon?
Ooh, 120 times.
I'm going to multiply, right?
Oh, yeah.
By what? 0.1, the decimal value. Okay, so I'm going to do 120 times 0.1. This is the 10% increase. So I'm going to get 0, 2, 1, move my decimal 2 places. So it's going to be 12 grams heavier. So what do I need to do to that 12 grams, Nick?
Convert it to ounces.
Not quite. I'm not ready to convert yet. What do I need? What is that 12 grams? What does it go towards?
Add it to the 120 grams.
Yeah, I'm going to add it to 120 because that's the original.
Grams.
Yep. So it's going to be 132 grams for now the new weight. Okay, so that's what he wants to do, right? Because he really wants to win the Pinewood Derby. Has anybody ever done the Pinewood Derby?
I have no clue what that is.
It's like where you make a little car out of this little piece of wood and then you race the car.
Yeah.
You and your grown
They
up.
don't do that anymore.
They don't do that anymore?
I
Maybe.
did that in 6th grade with Bob.
Okay. Oh yeah, I remember that. I remember hearing about those. Okay, so now we know how many grams his new car would weigh, but we have to convert it to ounces because that's how the race rules are written, right? So it tells us the conversion here, 1 gram equals 0.04 ounces. So let's go ahead and write that. And then I'm going to fill in the other part. Again, I'm going to keep grams in the numerator, ounces in the denominator, because we need them to line up. So I know I have 132 grams for the weight of the car. And then I need to find out how many ounces that is. So I'm going to do my loop-de-loop, 132 times 0.04, and 1 times x.
What is 132 times 0.04?
You tell me, use your calculator, man.
Oh my, I was multiplying.
Come on, use your calculator. Nick.
5.28.
5.28. So what does that 5.28 represent?
That would be the ounces.
Mm-hmm. Sean's car would weigh 5.28 ounces.
That would be over the requirement.
Yep. So can he do that?
No.
He we cannot do that increase. So in my third period class, we went through and tried to figure out how much he could add to the weight. And it turned out he could add, I think, like 4% to the weight and still be under the 5 ounces or less rule.
You guys just, so was it 5 ounces?
It was like 4.92. So let me see here. I'll do the math really quick.
I'm already doing it on my calculator. Yeah, it's 4%.
Is it 4%? You end up with 4 point
It's
something.
5% is 5.04.
Yeah, too much. Okay. All right, so as you can see, this took multiple steps. That's why it's called multi-step computation, right? So let's turn to question 2 and look at that one. We've got some fellas running a Spartan race. It's like an extreme obstacle course. I don't know if you guys ever heard of Spartan races. They're pretty intense. Okay. So we have Abe, Brandon, Cecil, and David. They're running the Spartan race. We're going to try to figure out what their combined time was. So we know Abe's time, and we know David's time. We don't know Brandon's time yet, and we don't know Cecil's time, but we know how they relate to the other times, right? So let's look down at the bottom where it says determine the total combined time in minutes. Everybody circle that word minutes.
Minutos.
Okay? So we need our time in minutes. How is it given to us in our question? Hours. So since we're going to be adding up and taking percentages of different time, we're going to go ahead and convert everything to minutes first. Because remember, like, time is funny, right? It doesn't go to 100. We have like 60 seconds or 60-minute increments, so we have to take that into effect. So we're going to convert it all to minutes so we don't have to worry about the weird parts of hours and fractions of that. So the first thing I'm going to do for Abe, if he has 2.5 hours, how many minutes is that? It tells us 1 hour is 60 minutes. So what's 0.5 of an hour?
It's 180 seconds.
Not quite. So how many minutes are in half of an hour?
Oh, 150 seconds.
There's 30 minutes in a half hour, right? So it is going to be 150 minutes. Or excuse me, it's 2.5, yes, 150.
Oh yeah, I meant minutes.
Okay, so we know Abe has 150 minutes. Okay. Brandon needs an additional 15% of Abe's time. So what are we going to do to Abe's time to get Brandon's time?
Times 0.15.
And then
Then you add it on.
you add them because it's kind of like a tip or a tax. You're adding 15% more on. So for Brandon, we're going to take the 150 minutes times 0.15. I'm going to use my calculator, guys. Smarter, not harder.
You said odd there.
Oh, that's an A. There we go.
I can't see.
22.5.
And you add,
Yep. So then we add 150 plus the 22.5. So Brandon's time is 172.5 minutes. And then we have Cecil. and he completed the course in 80% of Brandon's time. So what do I have to do to find Cecil's time if his is 80% of?
Time, or no, yeah.
0.8
Times
times
0.8.
172.5.
And then do I do anything with that value, or is that his time?
That's his time.
That's his time.
That's going to be his time because we're just finding 80% of 172 times the 0.8.
Wait, you said that. You said that?
So Cecil had 138 minutes. And then we have David's time, but it's in hours. So we're going to convert 3.25 hours into minutes. So what's a fourth of an hour? How many minutes is that?
15 divided by 4, 20, 15.
15.
15.
All right, because we have the quarter after, quarter till situation. Okay. I know.
20 behind.
That's crazy. Okay, so how many minutes is 3 hours and 15 minutes going to be?
195.
195 minutes. So they want to know the total combined time. We have all of these in minutes, so now we're just going to add these up. 150 plus 172.5 plus 138 plus 195. So it's not a super straightforward question. It does take some endurance, right? You can't give up in the middle.
Oh, I see what you did there.
See what I did there?
Yeah.
Yeah. Okay, let's take a look at the next question. Go ahead and read this one to yourself.
Or I can read it out loud.
You want to read it out loud, McCoy?
Yeah.
Go for it. Thank you.
Kate is making a hot chocolate drink for her friends after they went sledding in the park. Kate wants to make 4 liters of drink. That makes total sense. 40% of the drink needs to be whole milk. The store only had whole milk in quarts containers. Each container of whole milk cost $1.20. 1 liter equals 0.26 gallons. 1 gallon equals 4 quarts. How much will the whole milk cost in order to make this drink for all of this?
A lot, right? First thing I want you guys to do is cross out this conversion and write 1 liter equals 1.05 quarts. Okay, we're not going to have you guys do like double conversions this year, so I just wanted to change that. Make it a little bit like cut to the chase there on that conversion. Okay, so she's having her friends over. She's going to make some hot chocolate. She's very, very meticulous, right? She's not going to mess around with the recipe. I don't know about you guys, but when I make hot chocolate, I just like heat up milk and then I squeeze Hershey syrup in it and I like stir. So I don't have a recipe necessarily, but
I just used the hot cocoa mix and put it
the
in
powder
the
stuff,
microwave.
yeah.
I used to Swiss it though.
You use what, McCoy?
The Swiss.
Oh,
something
Swiss
brand?
Miss.
Yeah.
Yeah, that's pretty good. Starbucks hot chocolate packets are actually pretty good. They're just expensive.
I think that would help.
Yeah, but the
Use
Swiss
coconut milk.
I like from Starbucks is their vanilla coffee.
The Swiss Miss ones, you have to like put like 4 packets in for it to be good.
Do you get the one with marshmallows or no?
Sometimes.
Sometimes
I
marsh.
think they made caramel. I went to the store and I got caramel.
Yeah, the salted caramel is pretty good hot chocolate. Doesn't seem like it would be, but it's delicious.
I love caramel, but when I tried the Starbucks caramel coffee, I didn't like it.
Starbucks is terrible.
Okay, we're gonna move on because you know how I love my Starbucks, clearly.
Yeah.
Okay, so let's talk about Kate's hot chocolate again. Wants to make 4 liters. 40% of the drink needs to be whole milk. You can only buy it in quarts. This is the price of the whole milk per quart. Okay, so what would you do first? What would be your first plan of attack to whittle away at this problem? Kaden, what do you think you would do?
I would do the conversion.
You would convert 4 liters to quarts right away?
Yeah.
Okay, would anybody do something different?
No.
What about this whole 40% of the drink needs to be whole milk?
Well, I mean, you could do that and then convert it to liters.
Right. Right now she just needs to buy whole milk. We're just going to focus on this whole milk. So converting is definitely important, but I think finding 40% of 4 liters might be easier than finding 40% of however many quarts we end up with. So let's start out there. Let's find 40% of 4 liters. So how am I going to find 40% of 4 liters?
4 times 0.04.
Just times 0.4, right? 40%.
That's what I meant.
So I'm going to get 1.6. Okay, 40% needs to be whole milk. Fantastic. So that we need 1.6 liters to be the milk. Okay, I should probably write in liters of whole milk. Okay, so they only sell it in quarts though. So Kaden, what am I going to do with that 1.6? Now I'm going to convert it. So I'm going to draw my proportion. 1 liter equals 1.05 quarts. So 1.6 liters will equal how many quarts? So I'm going to do my loop-de-loop. So I have 1x equals 1.6 times 1.05. Use your calculators. What is it, Nick? 1.68. And that 1.68 represents
Quarts.
Kate needs 1.68 quarts of whole milk. Can you go to the grocery and say, I just need like 1.68 quarts, I don't need the rest of this, and just pay for that? Nope. So how many does she need to buy?
Nobody would ever buy a whole gallon of milk.
You don't think so? I don't know. My boys go through milk real fast.
I love milk.
Mostly because they waste a lot of it. Like I pour it in the cup, they drink like 3 sips, and I'm like, wow.
I used to do that.
I waste it when I eat cereal. I don't.
Yeah.
Yeah, that's the only thing.
Yeah.
Well, it depends on the cereal. It's like chocolate stuff, right? It makes the milk taste.
If it's cinnamon toast crunch, I would.
Yeah.
I don't.
I've heard good things about the Cinnamon Toast
Or
Crunch.
if it's just like regular rice cracks, because then it's just plain milk.
I
Yeah.
don't really like plain milk unless I'm like.
Yeah.
Okay.
Used to be allergic.
So how many quarts does she have to buy?
Milk.
She can't buy 1.68 quarts. So how many must she buy? Carlos?
Just buy a gallon.
How many quarts does she need to buy?
Like
2.
2.
Yep. She has to buy 2 quarts.
Can you even do that?
Yeah, they're sold in 1 quart containers.
Just get 2 containers of milk.
Oh. That's what you're sold in gallons.
All right, so how much is it going to cost her? Because remember, that was the actual question. How much will the whole milk cost in order to make the drink? $1.20
$4
times 2.
unless you have tax.
Well, a lot of food isn't taxed at the grocery. I know that sounds weird, but
Yeah.
a lot of stuff isn't taxed.
Maybe like items.
It will cost Kate $2.40.
Pour water.
Okay, so again, it's not easy to get from your starting point to your actual finishing, the answer, but if you just set up a plan. Now, Kaden, if you had decided to convert first, and then you still would have gotten 2 quarts. Your answer would have been the same. It might have just taken you a little bit longer, right? There's no wrong way to do it. It just depends on your strategy. Okay, let's go to the next page. Let's talk about this farmer. Okay, go ahead, narrator.
A farmer needs to repair and build some fences. She has a roll of fencing that is 100 yards long. First, she builds 5 identical fences for her vegetable gardens. Next, she uses 10 feet of the roll to repair a fence. After she completes this work, she has 40% of the original roll of fencing left. What length in yards of fencing is used for each vegetable garden? So all your work below and run your answer to the nearest one.
Perfect. Okay, so there's a lot happening here, right? We know she has 100 yards. And then this down here, this whole, she has 40% left over is actually really important, okay? So that means she only used 60% for the 5 gardens and the repair of the 1 fence. So this is actually what we're going to want to attack first. We're going to find out how much did she actually use.
60%.
60%. So I'm going to go up here and I'm going to say, all right, well, she has 40% left over.
That means she used 60 yards. If she has 40 yards.
100 times 0.4
No.
means she used, or she has 40 yards left.
But you know you didn't have to do that.
Well, I know, but some people need to see, like, where do we jump to the 60, right? Like, how do we get right to that 60? So I'm going to do 100 minus 40. So 60 yards were used. Okay. First she builds 5 identical fences. Then she used 10 feet just to repair a fence. Okay, so in order to figure out how much she used for the 5 identical fences, we have to subtract that 10 feet first. So then,
she has 50 yards left.
well, here's the thing, that's in feet,
Oh,
right? So
No.
now we're going to have to convert yards to feet.
3 feet equals 1 yard.
Right, so 1 yard equals 3 feet. So 60 yards equals how many feet?
This here was 3 times 60.
Guys, crack me up with your technology. 1x equals 3 times 60. So x equals 180 feet was used.
So is that the final answer?
No, it's certainly not. This is multi-step, right?
Yeah. What am I talking about?
All right, so she used 10 feet to repair a fence. So let's go ahead and take that 10 feet away. Minus 10 feet for the fence repair. And the more information you put on your work as you go along, the easier it'll be to strategize and keep it, you know exactly what you've already done, and then you don't have to be like, what did these numbers come from, right? So we now have 170 feet for the 5 gardens. And it said she built 5 identical fences. So how am I going to find out how much she used for each garden? Division by
Oh, 5.
5 identical
Oh, yeah.
fences,
So
right?
170 divided by 5.
So I'm going to take 170 divided by the 5 identical fences. 3.
Oh, wait.
34 feet
I said 34, so you're looking at
per fence.
it.
But wait, there's more. We're not done yet. What does our answer need to be in? Look back.
feet.
Yards.
Yards.
What is the length in yards?
Oh, now we have to convert.
Oh, Mrs. Marsh, this is torture. All right, so 1 yard equals 3 feet. So now our variable is with yards equals 34 feet. So I'm going to do my loop-de-loop. 3x equals 34. And what is 34 divided by 3?
How many spaces?
34 divided by 3
11.33 yards. So what's my final answer? What does that x stand for?
How many? How much you have left?
The farmer used 11.33 yards repeating on each identical fence.
These farmers are mathematicians.
Farmers aren't messing around. Again, this one took us a while, but you guys have all the strategies. You know how to find percents and you know how to do conversions. It's just a matter of being willing to work at the problem without just getting it right away. Okay.